In our previous video, we talked about the distance versus displacement. In this video, we are going to talk about some problems based on distance and displacements. Let's look at that. Let's look at the first problem. Let's say we have a ground, okay, which is like this, and this is the road on the circumference. Let's say the radius of this road, the circular road, is capital R, and let's say this is point A, correct? Now a person wants to walk from point A all the way up to this particular distance, right? From A to again A in a circular manner. Now what is the distance covered, right? What is the distance covered in this? The distance covered will be the circumference, so it is equal to 2 pi r, right? What will be the displacement in that case? Displacement is the straight line distance between initial and final position. So initial position is here and final is also here. That means the displacement is going to be 0. There is no displacement. So this is 0 meter. So this is 2 pi r meter. R will be anything. It will be given in the question. So this was case 1, right? The person went from A to A. Let's look at case 2. Suppose the person goes from point A to point, let's say this is B, okay, point A to point B along this circumference. Then what will be the distance covered? So obviously the distance will be half of that of the circumference, right? Because he has gone like this. So half of the circumference will be the distance. So this is half of 2 pi r, which is going to be pi r. Pi r will be the distance, right? And what will be the displacement? The A and B, between A and B, what is the shortest distance? This straight line, right? So this is going to be the displacement, which is equal to 2r. Why? Because the shortest distance is the straight line, which is having the length of 2r. Okay. Now let's say the person goes from point A to point C like this, okay, along this path. Then what will be the distance? They may ask like this. So this is your case 3, okay. So in this case the distance is going to be, see, now it is 1/4 of a circle, right? 1/4 of a circle is this circumference, this length of AC is 1/4 of a circumference. So this distance will be 1/4 into 2 pi r. So this is going to be pi r by 2. This is going to be your distance. And what is going to be your displacement? See, this is r and this is also r. What is the shortest distance between A and C? The shortest distance between A and C is this straight line, right? Okay. Now how will you find out this length AC? The answer to that is, see, this is r, and this is 90 degree. So I can say, according to Pythagoras theorem, AC is going to be, here I will write, AC square is equal to, let's call this as O, the center of the circle. AC square is equal to OA square plus OC square. But OA and OC both are R, so this will be 2R square. So AC is equal to square root of 2 into R. This is going to be your AC, the hypotenuse length, right? Okay. So this is your displacement. Now same thing will go if this person goes from all the way from A to this point, let's say D. Now it is 3/4 of a circumference distance, right? So it will be 3/4 of 2 pi r, and again the displacement will be like this, okay? Now since we have given the magnitude of displacement, we should also give the direction, right? So what will be the direction? Okay, if this is r, this is 90, that means this is 45 degree, right? This is also 45 degree. So displacement is 45 degree from the y-axis, okay, right? Or you can say 135 degree from the x-axis, right? Okay. Yeah. So now let's look at what happens if somebody asks you, the person, let's say this is point maybe S, and the person goes from S to T. Now this is, let's say, angle theta. In this case, what is going to be the displacement and the distance? In that case, what you will do? The answer to that I will tell you. Let me just erase this. Okay, so let's say we take an arbitrary circle. I will just write it towards left. Okay, I took an arbitrary circle, and let's say this is point O, and let's say this is the starting point A. Okay, since the marker is not that much visible, I will use another one. Okay, let's say the person goes from point A. Let's say this is radius R. Okay, person goes from point A to this particular point B, and in going from A to B, the person traversed an angle theta at the center, right? Person traversed an angle theta at the center. Okay, now what is going to be the displacement and what is going to be the distance, right? So now let's say this is R and this is the arc length. Let's say L is the arc length. We know this formula, theta is equal to L by R. Theta is equal to L by R. So L is going to be R theta. So now you can get the distance if you know the angle theta because of this formula. You know this formula, right? Okay. Now I want to know displacement. How will I know that displacement? See, the displacement from A to B is this straight line. Now obviously A to B distance, A to B straight line is not equal to arc length because arc length is like this. Now what you will do? See, what we can do is we can drop a perpendicular from this point. Okay, I will tell you why I am doing this. It is because I can have this right angle triangle and the hypotenuse of that right angle triangle is AB. From that we will get the answer C. Let's call this point as C. Okay. Now what is this length BC? If I see here cos theta, R cos theta is OC. See, R cos theta is OC. So OC is equal to R cos theta. Very good. And what is BC? R cos theta is OC. So R sin theta is going to be BC. BC is equal to R sin theta. Right? Very good. Now, what we can do here is that we want to find out AB, right? To find out AB, you need BC, which is R sin theta. But you also know, you should know AC as well. But what is AC? See, I can see that AC is equal to OA minus OC. OA minus OC. So OA is nothing but R, capital R, minus OC. What is OC? R cos theta. So R cos theta is like this. So I got AC as well as BC. So from that I can get AB. So AB, according to Pythagoras theorem, is going to be square root of AC square plus BC square. AC square plus BC square. So this is going to be square root of AC is R minus R cos theta whole square plus BC square is R sin theta whole square. So this is going to be, see, I can take R square outside, so it will be R square root of 1 minus cos theta whole square plus sin theta whole square. So this is going to be R into square root of 1 minus 2 cos theta plus cos square theta plus sin square theta, right? Okay, so cos square theta plus sin square theta is 1 and that 1 plus 1 is going to be 2. So this is square root of, R into 2 minus 2 cos theta. Now if I take 2 common, so what I will get? Square root of 2 into 1 minus cos theta. But 1 minus cos theta is 2 sin square theta by 2. So this is going to be R into square root of 2 into 2 sin square theta by 2. If you know the trigonometric identity, right? Let me check if it is visible. Yes. Okay, now this is 4. So 4 square root is 2, sin square theta by 2 square root is sin theta by 2. So this is going to be 2r sin theta by 2. This is going to be your displacement. This is going to be your displacement and the distance is this. Okay, so if somebody asks you what is the displacement if the angle traced is some theta, then just put that value of theta in here. Okay, right? So let's check if this formula is correct or not. How we will check? In the previous case we did some distance and displacement calculations for different thetas. So let's use that. For theta equal to 180 degrees, we got the displacement to be 2r. Let's check if we are getting that. If theta is 180, that means this should be pi. Okay, this should be pi. So sine of pi by 2 is 90. Sine 90 is degree in degrees, which is 1. So it is 2r. That is correct. If we did theta equal to 90 degree, then you should get root 2r, right? So let's check. If theta is pi by 2, then I am getting sine pi by 4, which is 1 by root 2. So 1 by root 2 by 2r by root 2 is root 2r. So again I am getting the same result. So this is a correct formula. And of course this is also a correct formula. Okay. So let's look at another question. Okay. Okay. So let's say we have an ant, okay, or a bug, and that ant or bug is at this corner of this cuboid. Okay, let's say this is a room, cuboid room. Okay, we have the length of the room as L, the height as H, breadth as B. Now what this ant do is that it goes from this point, let's call it as point O. Okay, let's call it as point O, starting point. It goes from point O to, let's say, this point A, and then from point A it goes to point B. Correct? Yes. Now and then what he does, it goes from point B to point C. So O to A to B, B to C. O to A to B, and B to C. It has gone like that. Now we have to find out the distance covered by this ant and the displacement of the ant. Let's look at that, how we can do this. What will be the distance? See, first this is the L, that is the length, then height H, then the breadth B. So simply the distance is L plus H plus B, right? L plus H plus B. This is very easy, right? Now what is the displacement? So starting point is here, ending point is here. Now I have to join both these, right? This is the straight line. The length OC will be your displacement. So displacement is equal to OC. Displacement is equal to OC. Now how will I find that displacement? Simple. Let's say this is let's say D, right? Let's say D, and let's draw a line from O to D. Now if you look at this is a triangle, right angle triangle. These are the two opposite corners of the room. You can see this is one corner and this is the opposite corner. So this can be said as the body diagonal. Okay, how will you find the length of the body diagonal? Now if I know this is going to be right angle triangle, right? So OD square plus DC square is going to be OC square. So OC square is equal to OD square plus DC square, right? What is OD? I don't know. DC I know, which is height H. So DC, let's write it as H square. But what is OD? I don't know that. But now if you look here, OD is nothing but the hypotenuse of this triangle OAD, because this is also 90 degree. It doesn't look like 90 degree, but it is a 3 dimension. You can imagine like a corner of a room. This is a room and this is a corner. So this is 90 degree. So this is 90 degree. So OD square is equal to the OA square plus AD square. OA square plus AD square. But AD is nothing but the breadth of this room. So AD square is B square. And what is OA? OA is nothing but the length of the room, which is L square. So OD square is L square plus B square. Now OD square plus OC square, OD square plus DC square is OC square. So OD square you can put it here, L square plus B square. This is going to be your OC square. So OC is equal to square root of L square plus B square plus H square. This is going to be your displacement, right? Okay. Let's look at the next question. There is a wheel over here, okay, and this is a ground or a road, whatever it is, and this is a point which is in contact with the ground. This is the point of the wheel in contact with the ground. Now what happens? The wheel rolls forward like this. Wheel is rolling forward like this, and after a certain time, after rolling, this point A comes on the top, the topmost point. Let's say this, let's call this as A dash point. Okay, so this point itself is this one after one some rotation, right? Okay, now yes, like this. Okay, so what we have to find out is what is the displacement from A to A dash. What is that displacement from A to A dash? What is that displacement of that particular point? How will you do that? See, first of all, it has come from this to topmost point. That means the rotation should be the half rotation, not full rotation, because if it was a full rotation, it would have gone all the way up and came down, but it gone all the way up to this only, so it is a half rotation, right? So it is a half rotation, and let's say this is point A, this is point A dash. I don't know, let's call this as point B. Okay, now what is the displacement between A and A dash? The displacement is of course the straight line like this. Okay, and now this is a 90 degree, right? Now we have to find out that. Now let's say this is your radius r, this is also radius r, correct? And what is this distance? Of course this distance is going to be your half of the circumference, because it has gone half the circumference, right? So it has traced the half circumference, which is going to be pi r. Now simple to find out A dash. Why? Because it is a right angle triangle. You know A dash B, you know AB. So you can find out what is A dash. So what is A dash? A dash is equal to square root of AB square plus A dash B square. AB square plus A dash B square. This is going to be your A dash. So square root of AB square. What is AB square? Pi r square plus A dash B square. A dash B is 2r. So this is going to be 2r square. So this is equal to square root of pi square r square plus 4r square. So r into square root of pi square plus 4 is going to be your displacement A dash. This is going to be your displacement A dash, right? Okay. So now here there will be variations of these questions as well for little higher level, JEE advanced level, you can say. This is a half rotation, right? What if they say, what if the point is not exactly here, maybe somewhere here or here or here? That is not complete rotation, not half rotation, not 1/4 rotation, whatever. It can be any nth rotation. Nth rotation. It is not complete or half like that. So in that case, what you will do? Okay. So let's see what happens if the rotation is not complete. Let's say this is the point again A, and it has gone some distance. It has rolled. Okay. Let's say from point A, and that point A came till this point. Let's say this became A dash. Okay. From here to here, it has gone. It is any arbitrary rotation. In that, it has covered an angle theta, right? Let's say this is angle theta. Okay. Now, if this is angle theta, this is a radius, of course, r, and this is also radius r. Let me take it little bit lower. Let me take it little bit lower. Otherwise it's okay, let it be. So let's take this center. This is radius r. Let's say this is angle theta. It has covered it has gone by angle theta. So of course this length I know. Let's say this is B. Of course this length is going to be your see, for angle 2 pi, for the tracing of the angle 2 pi, you are completing 2 pi r, that is circumference, right? So for angle theta, how much you will cover distance x? So this is going to be cross multiply 2 pi r into theta by 2 pi, which is r theta, which is basically your arc length, right? So the arc length is r theta. So this is going to be your r theta, correct? Okay. Now let's say this is A dash, right? Now what is the displacement? So from A to A dash, you draw a straight line like this. Okay, from A to A dash you draw a straight line and you drop a perpendicular here. Always you have to use these things. Okay, and let's call this as point C. Now what is going to be your AC? See, observe that. What is AB? AB is r theta. What is BC? If I find somehow the BC and subtract it from AB, then I will get AC. So let's draw perpendicular here like this. If this is R, this one is going to be your R cos theta. The component of this line along this is R cos theta and the perpendicular component is R sin theta. So now obviously BC is going to be R sin theta. So if BC is R sin theta, what is AC? AC is R theta minus R sin theta. R theta minus R sin theta. This is going to be your AC. What is A dash C? See, A dash C is nothing but, let's call this point as D. A dash C is nothing but BD. See, yeah, this is BD, right? This is BD. So BD is nothing but R minus R cos theta. So A dash C is R minus R cos theta. Correct? Okay. Now let's find out what is A dash A. A dash A is equal to square root of AC square plus A dash C square. AC square is of course R theta minus R sin theta whole square plus A dash C square. What is A dash C square? A dash C is R minus R cos theta. R minus R cos theta whole square. This is going to be your A dash C. Right? So you just put your value. See, R I can take it out. Okay. So it is going to be square root of theta minus sin theta whole square plus 1 minus cos theta whole square. Right? Now this is your displacement. Right? Okay. Now just see if this is correct or not. How will you find out? For half rotation we had R times square root of pi square plus 4, right? So let's check if it is coming out to be true here. So for half rotation theta was pi. So if I put here, this is pi minus sin pi. Sin pi is 0. So this is pi square. And this is 1 minus cos pi. Cos pi is minus 1. So this is 2, 1 minus of minus 1, which is 2. So 2 square 4. You can check it. It is correct. So now, if you know this theta, you can find out the displacement of that point. Okay, for any theta, any general theta. If you want to write in terms of the rotation, maybe they have said it completes n rotations, then what you will do? If n rotations are completed, then simply you just convert theta into n. How will you do that? Okay, see, for one rotation, what angle is covered? 2 pi, right? For half rotation, what angle is covered? Pi. So for n rotations, how much angle will be covered? Let's say theta. So now for one rotation it is 2 pi. For n rotation this is theta. So theta is equal to 2 pi n. So just put your 2 pi n value as theta here. And then you will get the displacement, right? Okay. So these are the questions based upon distance and displacement, right?